Hiya! So in this lesson we are going to calculate the final temperature of a mixture. First, some background theory. When two objects are put next to each other, or two liquids mixed together, they will eventually come to have the same temperature. This is what we know as thermal equilibrium. So in thermal equilibrium, what's happened is heat will transfer from the hotter object to the colder one. In other words, the hotter object loses heat and the colder one is going to gain that heat, the same amount of heat. So we express this as heat loss is equal to heat gain. Now remember the last lesson when we learned about the equation for heat. Heat is equal to mass times heat capacity times the change in temperature. We are going to combine this equation with the equation from the last slide. Heat loss is equal to heat gain, and we're going to have mass of the hot water multiplied by heat capacity of water multiplied by the change in temperature of the hot water equal to negative of mass of the cold water times heat capacity of water times by the change in temperature of cold water. Now the reason why we have the negative there is because we've got heat loss and heat gain. They are the opposite of each other, so we need to have that negative there to show that they are opposite. So to expand out the change in temperature, the change in temperature is equal to final temperature minus initial temperature. So we got a big equation here. So mass of hot water multiplied by heat capacity of water multiplied by brackets final temperature minus the initial temperature of the hot water, and that's going to be equal to negative mass of the cold water multiplied by heat capacity of water multiplied by brackets final temperature and minus the initial temperature of the cold water. You're probably going to ask, why is it that we just have one final temperature? And that's because, remember, both the hot water and the cold water will come to the same temperature. So we're just going to use one final temperature for the both of them. Another thing that we can do here is, because heat capacity of water is the same on both sides, we can cancel that out, and so we have a smaller equation. Mass of the hot water multiplied by brackets final temperature minus initial temperature of the hot water equal to negative mass of the cold water multiplied by final temperature minus the initial temperature of the cold water. Now the last equation here is what we're going to use in our calculation. So what you can do is, you don't have to worry about the last few steps. That's just to explain you how we come to this equation here. In the exam, to save time for you, you probably just want to use the last equation. You probably want to write this in your book or your notes somewhere, so that in the second exam you can use this. Let's try out some question. So we got two samples of water. They were mixed together. One water sample that was 300 ml with a temperature of 18 degrees Celsius was combined with another sample that was 200 ml with a temperature of 81 degrees Celsius. And the question asks you to calculate the final temperature of the mixture. what we need to do first is we need to highlight or underline all the key informations. So we got 300 ml and 18 degrees Celsius. So this is going to be our cold water, and 200 ml with 81 degrees Celsius. This is going to be our hot water. Step 1, we're going to convert everything to SI units. So 300 ml of water at 18 degrees Celsius, that gives us mass of the cold water being 300 grams, and that's going to equal to 0.3 kilograms. We've also got 200 ml of water at 81 degrees Celsius. That's going to be equal to mass of hot water being 200 grams equal to 0.2 kilograms. So remember, 1 ml is the same as 1 gram. Our second step is to calculate the final temperature. So remember the equation that we got before. We're going to put everything that we know in. So we've got mass of the hot water there, 0.2, times by final temperature minus by 81, which is the initial temperature of the hot water, equal to -3 times the final temperature minus 18, which is the initial temperature of the cold water. What we are going to do next is we are going to expand out the brackets. Okay, so 0.2 multiplied by final temperature, and then 0.2 multiplied by minus 81. We're going to do that the same on the other side, and we get 0.2 T final minus 16.2 equal to negative 0.3 T final plus 5.4. What we're going to do now is we are going to rearrange the equation so that we got the final temperature T final on one side and the rest on the other side. So the way that we can do that is we can plus 0.3 T final to both sides of the equation, and we can also plus 16.2 on both sides of the equation. Okay, so now the 16.2 is going to cancel out, and the 0.3 T final is going to cancel out as well. Now you're probably going to be more familiar with moving terms from one side to another, and you can do that as well, and that's fine. The principle behind moving something from one side to another is the same as this one. Basically, when you move the negative 0.3 T final to the other side, that's basically just plus 0.3 T final. And when you move the negative 16.2 to the other side, that is the same as plus 6.2. So you can use either way, it'll be fine. Just use the one that you are most comfortable with. So with everything cancelled, what we have left is 0.5 T final equal to 21.6. So what we want to do next is we want to divide both sides by 0.5. And our final answer, our final temperature would be 43.2 degrees Celsius. So to summarize, for this type of question, what you want to do first is you want to convert anything that is not in SI units to SI units. So mass has to be in kilogram. And the second step is to calculate the final temperature using this equation here. It may be a good idea for you to copy this down into your book somewhere, so that you can use it for your test and exam. Alright, so I hope you have fun revising and good luck with your test. Bye.